Welcome to our first office hours of the Explorer Expander Bootcamp. I'm joined by Lev today, who is going to be the moderator or is the moderator for the track on GKR proof recursion. And so today we're going to kind of tackle, I think, really two primary topics. One, I know Lev has spent some time putting together a document on all the work that he's done and where he thinks we can take some of the technology that he's discussed and apply that to solving real world problems. And so we'll dive into that and give you guys some ideas for where you may want to focus your efforts as you're starting to build. And then for those teams that may have already started building and have questions or areas that they have been getting stumped or may require some help, we can use this as an open discussion forum because if you're having any issues or you have any questions as you're working on development, it's probably something that other teams may face down the road, and so this would be a good venue for us to discuss those. So without further ado, I'll turn it over to Lev. And Lev, welcome back. Great to have you. Yeah, let's dive into to the doc you put together and some ideas around where they can apply the knowledge that you shared with us a couple weeks ago.
Yeah, okay. Hello, everyone. So I will put a link in the chat once again. So it's quite a brief explanation of what I'm suggesting to do. For some reason, it doesn't pick the full link, but you can copy-paste it manually. Okay, I will just share my screen and quickly go through this document. And then if you have any questions or really, if you have any questions at any point, just ask them. Okay, so this is like a very high level guide on what we want to achieve. So so what we want to achieve is like GKR proofs are quite large, and we want to compress them by using more GKR to eventually, but like okay, by using GKRs with lesser and lesser amount of layers to finally achieve the proof of reasonable size. And so like I have like brief outline of how this should be achieved. I think at first you need to define verification IR. And I think that is something that does not exist. Okay, it exists in many forms, but you will probably need another one. And I do not think it exists in Expander. And this would be a very nice addition to Expander anyway, even if it's just the only thing that you're doing. So basically, this is like a language which has operations that we're trying to verify. It should involve arithmetic constraints, and it should involve hashes. And the reason, yeah, and okay, I will skip some details. The idea is that the verifier will then need to compile to this IR. Like your favorite GK, then you will need to teach your favorite GKR framework to compile verifier into this IR. And like people typically do something like this when they do recursive verification. So this is like a fairly standard thing that you probably will need to do. So importantly, our IR does not involve any manipulations with elliptic curves, because we only want to perform the verification of the tail of GKR, which is like some checks, and they only involve hashes and arithmetic operations. And so so basically, so it's like not a full recursion, we are only compressing the tail. yeah, you will need to do this. And now we basically make a special form of PLONK, which is able to call GKR. So the reason for this is because GKR by itself is not good at control flow. I even used stronger words here, but this is actually correct. Because if you do like random wiring between two layers, the verifier will blow up. And so to get some it is somewhat decent at control flow of data parallel circuits, and I think that Expander attempts to lay out it in a sensible way. So if you want to use Expander, I think it is okay to just write a circuit if it is data parallel. At least this is what Jinfei told me. But like if it's not the case, I mean Expander compiler. But if it's not the case, you will probably need to write it manually. But anyway, only circuits that we are going to use are circuits doing something a lot of times. So, so we will take protoboard will take like it will deal with the control flow, and we will only use GKR for highly data parallel circuits. So if you remember in GKR you have like inputs to the protocol, and basically the PLONK lives on these inputs. So like you get like control flow on the set of inputs. And this is also another desirable feature, basically not going strictly GKR or strictly PLONK, but using PLONK and using GKR as an accelerated coprocessor for some like data parallel stuff. So, so this is another feature, which is also a good standalone feature that should be done at some point. Specifically, what I'm suggesting is that we have like collection of columns, or maybe each of the CIs is like multiple columns, and they represent the phases of our protocol. And so C0 does like it represents commitments done by like our original protocol. C1 it runs the verifier, the some check part of the verifier of this protocol up to all the hash operations. And then the hash operations are copied to some particular column of C1, which like represent and then we run a GKR protocol on this hash operations to like verify that all hashes were done correctly, and this is verified by C2. So basically, each CI hosts the GKR, the verifier of the GKR protocol of the previous collection of columns. So the idea is that we will be gradually decreasing the depth of the GKR circuit. For example, imagine you are doing like 10K Poseidons. Then GKR verifier wants to do roughly 1,000 Poseidons, and this is like normal. Like if you want to do 10K Poseidons, you can run GKR, and you will compress it to do only 1,000 Poseidons. But if you are doing something around, I don't know, 700, like this is rough estimate, I don't know exact number, but roughly 700, you will get to the point that GKR verifier also wants to do 700 Poseidons. So instead, we will aggressively chunk the Poseidon into pieces. So at first stage, we will run monolithic. I think like 3 stages is probably roughly optimal. So at first stage, I suggest that we run like a monolithic Poseidon circuit. On the second, we run a circuit which does 1/4 of the Poseidon in one go. And so it like commits to 4x more data, but it like has 4 times smaller depth. And I think on the third layer, it is probably okay to actually do something very shallow, like, for example, a single layer with nonlinear fifth power operation and some linear combinations that you use to do Poseidon. So Poseidon is expressed as fifth power operation and some linear combinations. And you can check Neptune strategy of Poseidon to understand how it allows to deal with partial rounds, because basically chunking Poseidon more than in few pieces is not actually effective due to how it works, and you can check the Neptune strategy to understand more about it. So there is a bit of a difference compared to normal PLONK. So so protoboard itself should run HyperPlonk protocol, but it also need to connect outputs of some like protocols that it's actually running with inputs. So HyperPlonk verifier needs to be modified a bit. Specifically, the CI is fed as an input, or at least some columns of it are fed as an input of Fiat Shamir of the IVE protocol, which is being simulated inside of CI+1. So your verifier will need to take the commitment to the column CI, parse it, and feed it back as a public input to CI+1. Okay, so we can put it inside of Fiat Shamir. And similar thing happens with the final opening claim. So if run, which is run by CI+1, will be returned as public output, and it will be validated by HyperPlonk opening argument. So, okay, why is this sound? This is like not written anywhere, and like the first place when I'm like describing this scheme is like this bootcamp. So obvious question is, why is this even sound? So my argument is as follows, that CN faithfully executes the verifier. So it justifies that the run of CN-1 is correct because CN was faithfully executed. And so you like inductively check that like parts of this protocol are actually correct. So yeah, and this is roughly my suggestion. So even parts of the suggestion I think are important. For example, having verification IR is important for any effort of doing recursive stuff, even if you're not planning to do this particular kind of recursive stuff. Just having an IR for verifiers is very important. And combining PLONK with GKR in general is also a very important thing, because once again, GKR excels at data parallel circuits, and PLONK excels at control flow. So okay, maybe not excels, but it's okay with I mean not control flow. I mean like I don't know how to say it exactly, but it is good at copying data in arbitrary places. So yeah, and overall, I think that with this scheme, you should be able to achieve like sort of like compressed GKR proofs that look basically like HyperPlonk with maybe small twists, like parsing some commitments and feeding them as public inputs to some other parts of the proof. And overall, they should be quite small, like in, I don't know, a few kilobytes max. So this is like my suggestion. Okay, I think I'm mostly done. Can I stop sharing?
Yeah, you can
Because it
stop
will be
sharing, and
recursive.
you
Yeah, cool.
actually answered the first question that I was going to ask was, okay, let's, these teams are going out and making progress, or they've built an MVP and want to measure their performance that they're seeing on their benchmarks to, what you would expect. It sounds like, a few kilobytes is what you're looking for from a proof size perspective.
Yes. So first of all, so currently, basically, we have a problem that it's very hard to verify Starks on chain. And also very hard to verify GKR on chain, because like verifiers are just large. And the solution to this like is making like relatively bulky and I don't know, quite typically people make a gross 16 verifier for Starks or gross 16, they can build a gross 16 verifier for GKR. But this is not efficient, and you need like actually quite bulky machine to even compute this proof. And like to unlock a lot of, basically to unlock usage of Starks for like client-side proving. For example, you want to have a like cheap way of wrapping the Stark or wrapping the GKR protocol. And by the way, all of this is also related to Starks, because you can start with a Stark. You can do this GKR compression, but start with a Stark. Because bulk of work in Starks is also Poseidon's. So basically, this should be a very, in my opinion, a very important direction. And yeah. So this is, in my opinion, an important direction.
Got it. Amazing. I know we have quite a few members in the audience right now, and it does seem like the chat messages may or may not be coming through. So if you do have a question and for Lev or for the Polyhedra team, feel free to raise your hand or type it in the chat. I guess, Lev, are there any particular areas that you expect people to encounter difficulty, or like where would you say there are potential potholes or places where people might get tripped up?
Well, I think it's actually quite. I think it's a large project in a sense that it might be. Yeah, okay. Valid submission only if the code improves performance. Like, I think if you do it, like if you actually do it, it would already be a valid submission. Okay, this is actually not a question for me probably, but this thing is hard enough that just doing it at all is probably good enough. Of use cases of similar implementation. New message, GKR used in any ZKVM. Okay. I will try to. Okay, a lot of questions. So let me go through them in no particular order. Can you maybe share some Go examples of use cases of similar implementation? No, I can't. Is GKR being used in any ZKVM? Yes, a lot of ZKVMs trying to use GKR. The most famous example is Jolt, which is using class argument, but they are using it specifically for lookups. Some VMs are trying to use it more generally, but there are some important subtleties. There are some important subtleties, but in general, GKR is a good. So you can think of it sort of like a GPU for PLONK, in a sense that it is really good at data parallel circuits. And so if you have some operations that you are doing a lot of time and that only involves arithmetic, you probably want to use GKR. For example, if we have a non-trivial business example, is that a valid submission? I'm not sure, but likely no. You need to actually provide working code, I think. Would there be a need to implement a solidity polynomial library? I think if you manage to do verifier, which is based on like a bunch of hashes and elliptic curve operations, somebody will be able to code it in solidity. The most important part is just having the compression itself, at least for me. With benchmarks against other ZK protocols. I'm not sure how you want to compare it. Like this thing, okay, whatever. For the proposal, good starting point in the implementation. Well, okay. So good starting point is either implementing IR, verification IR, and teaching your favorite GKR framework, probably Expander, but like I use different GKR framework. I'm sorry, but whatever you choose as your GKR framework to compile to this IR, and another good starting option is picking some library for PLONK, for example, Halo 2, or maybe I think Halo 2 is probably a good choice, even if slightly unruly, and plugging in GKR protocols inside of it. So you can have like combined PLONK plus GKR behavior. Right now, Expander sadly does not have it, but it would be very nice to have it. So these are like two potential entry points. Yes. So if elliptic curve operations were to be added to the IR, how would you design IR to efficiently handle? Oh my God! No, okay. There are no free lunch. No free lunch, sadly. So the reason why we are not adding elliptic curve operations is because just not a lot of them, and so instead we just sort of do them on the verifier side. Because like it's basically a PLONK. But if you were to aggregate a lot of elliptic curve operations, you can do it with GKR. I actually have a project about it. It's called GKR MSM, but it's quite involved. So you can do it, but I would not say that it is not increasing the complexity of GKR framework. It's like you can make a GKR circuit which does elliptic curve operations, especially if you have a lot of them. But it comes at a cost, like mostly mental cost, because like you need to like basically do a lot of custom stuff. So I would argue that like the main point of recursive GKR compression is that you are not doing elliptic curve operations and only compress the tail, the some check part of the GKR protocol. And so you avoid doing elliptic curve operations inside of a circuit for now. So it might be easier to write than full recursion. Okay, I hope this answers the question. Yeah, okay. Yeah, I think I'm done. Mhm.
Awesome. Oh, we have one more question just came in,
Yeah,
snuck under.
okay, let's go, sure. What would be ideal deliverables for? Well, I think ideal deliverables is like, okay, I think I think that in the end you should have a. I would not say that solidity is like crucially important, but we want to have something that can be in theory verified on chain. So my suggestion is that like final goal is having a wrapper for GKR, which can be run on I don't know relatively mid laptop in less than half a minute. Like something not too crazy, but like this is like I don't know 50x faster than what we currently have. Yes, and the resulting proof should be small enough that you can potentially verify it in solidity in like less than I don't know 500,000 guess or something. Yeah, curious question: what are some benefits building something like that of a delegated, large, and trusted prover and the weak verifier? Also, what are the security assumptions for GKR compared to other protocols? Okay, you can ask me any questions. I can answer. Stuff related to anything related to GKR. Like, ask me anything. I will try to answer to my like to the best of my abilities. Okay, curious. Benefits building something like that of a delegated, large, and trusted prover. Okay, I don't understand about large and trusted prover. Proof delegation for GKR is kind of hard as far as I understand. I mean, or maybe not. I mean, it's definitely at least multi-round. Most popular way of doing delegation right now is based on collaborative snarks. And they best work for gross 16 and slightly worse for PLONK. Maybe you can adapt collaborative snarks to GKR. It might be an interesting thing. What are security assumptions for GKR compared to other protocols? GKR is secure as an interactive protocol. Recently, we have found an interesting. So it is transformed to a non-interactive protocol using Fiat Shamir transform. We have found some interesting issues with Fiat Shamir transform recently. Спасибо. And yes, we were, but it only applies if your GKR circuit is very large. So if your GKR circuit is very large, some weird things start to happen. Basically, Fiat Shamir heuristic itself seems a bit on a shaky ground in context of GKR protocol, but like for extremely large circuits. Okay, any dedicated group for GKR compression only? I have no idea. I'm sorry, but yeah, I will. Whatever.
So Lev, I guess we are generally, sending people to the bootcamp channel in the Polyhedra Discord, but if people are interested in, reaching out to you, are you interested?
Yeah, they can DM their unsolicited questions to my Telegram.
Can you share your Telegram in the chat for them?
Yes. Just like right here. Oh, and I guess chat is recorded and a lot of people will. Okay, whatever. It's public anyway. But yes, like ask me anything.
So there you
I'll try
go.
to answer.
If you'd like to reach out to Lev, you have his Telegram in the chat. If you have general bootcamp questions or hackathon questions, or want to reach out and ask any questions about Expander, our GKR based protocol, feel free to please join our Discord. I think, Lev, this has been super helpful. I think that we've gotten a lot of clarity around kind of what you're looking for and a great outline on how you might approach this if you were going to tackle this. So that has been really helpful. What I would love to see from this group, because we'll be having these office hour sessions for the next few weeks, would be, for those of you that are excited about this project and believe that you're going to, build something in this track, it would be great to have some teams that have made some progress or attempted to do some of the steps that Lev has outlined for us, so that next week maybe we can have, some questions about, okay, well, we're trying these implementations and we got stuck on this step, and we can really get into the weeds as far as, some obstacles that we may face when trying to do this implementation.
Yeah, and if anyone actually tries to do this, you can also like DM me with like your code or whatever if you have any. Like I can try to read your stuff, especially if it's in Rust and not Go. I might be able to actually read it, and maybe I can help. I'm kind of busy these days, but you can try.
All right.
Yeah. If you have any question about this track specifically, just DM me in Telegram.
Great. All right. Last call for questions. We're a couple minutes over, and as Lev said, he's busy these days, but so we really appreciate him taking the time to share with us today and to answer these questions. And thanks to the audience for all of the thoughtful questions. I think there's a lot of good stuff here. I definitely learned about a lot. We got one more: run in Rust/C in, I think we could run Rust/C in Go.
And, yes, and I can. Okay, whatever. And I can run Go in Minecraft, but
You could do whatever
that
you
is not
want.
that is not and run GKR in Minecraft, by the way. But whatever.
All right. Well, we'll leave it on that one. Git implementation of is the Git implementation of GKR interactive?
Not sure about Git, but most implementations are non-interactive.
I was gonna say I don't know what Git implementation you're referring to, but most of them are. Yeah. Maybe follow up with us in the Discord with that question. Okay. Lev, appreciate you taking the time. Everyone, audience, appreciate you guys tuning in. Really excited to start to see the work that comes out of this track. I think that there are some awesome kind of real world applications that could benefit if we are able to accomplish what Lev has kind of set us out on our journey here. So good luck. Would love to see some teams start building over the next week or so. And then next week we'll be back and hopefully we can answer some questions specific to the implementation that you guys are working on. Appreciate it. Thank you, everyone. Thanks, Lev.